Page 50, order of operations. Let's talk about some vocabulary first. So exponents are used to represent repeated multiplication. So for example, 3 squared is 3 times 3, 2 3s. 5 to the 4th is 5 times 5 times 5 times 5, 4 of the 5s. In exponential notation, we call the base, that's the thing that's being raised to a power. So in 5 to the 4th, we've got our base. Oops. We've got our base right here. And then the exponent is the little number, the power it's being raised to. So using that same example of 5 to the 4th, now the exponent is that 4. Let's look at a couple exponents that we can just evaluate. So we'll start with 5 squared. That's 5 times 5. 5 times 5 is 25. 3 cubed. That's 3 times 3 times 3. Well, 3 times 3 is 9 times 3 is 27. I like to keep track on my fingers of how many I've done. That's helpful when you have something like 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This lets me keep track. And we can do it with variables. We'll see that later. Harder to evaluate unless we know what the variable is. We can also have something like 3 squared times 7 cubed, in which case I just write out my 2 3s and my 3 7s. I know that 7 cubed has 343. 3 times 3 is 9, so this is 9 times 343, which we could figure out, well, that's almost 10 times 343, right? So that's 3,430 minus this 1, because I didn't really have 10, I only have 9. If you didn't follow that, not a big deal. We can always use our calculator, but if I'm doing this correctly, you'll see 10 of these minus 1 of these is going to give me 9 of these, which is what I want. So 3,000, so 0, 13 minus 4 is 8, because I have to borrow from this one. So I think I get 3,087. And again, feel free to use your calculator to check it. Grouping symbols. We have parentheses. We have brackets. Sometimes I call them square brackets. We have braces. Sometimes I call them curly braces. We have absolute value bars. And even fraction bars. Those are grouping symbols. We use grouping symbols to clarify which operations to do first. Start here. Sometimes there's more than one. So if there's an expression to be simplified inside a grouping symbol, follow the order of operations within the grouping symbols first, and then work your way out. And we'll see several examples of these. So order of operations tells you which rule to do. By operations, we mean addition, subtraction, kind of listing them in the order that they were learned, multiplication, division, and yes, exponents, last one that you typically learn would be roots. Like a square root or a cube root or a fourth root. All of those are just called roots. So here's what we do. We perform all operations within grouping symbols first. Start with the parentheses or the fractions or whatever's being held together with those grouping symbols. Then we evaluate exponents or roots. And then multiply or divide, whichever comes first from left to right. So I do not do all my multiplication and then all my division, or the other way around. I just work my way from left to right. And finally, we add or subtract. So it's kind of the reverse order from how they were learned. Grouping symbols, then the exponents or roots, then multiply or divide, then add or subtract. And just like multiplying and dividing, adding and subtracting, we're going to do whichever comes first from left to right. So we don't do all the addition and then all the subtraction or the other way around. To help you remember, you can use PEMDAS or please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally, which stands for parentheses and other grouping symbols, exponents and roots, my dear multiplication and division, whichever comes first from left to right, and then addition and subtraction, whichever comes first from left to right. Notice that there are other abbreviations. For example, many other countries use this one. They say brackets instead of parentheses, that's fine, but they mix up the D and the M. That doesn't matter, right? Because we're doing multiplication and division at the same time. So this is a good way to remember that it's just going from left to right at each priority level. Multiplication and division are the same priority. Let's get some examples. So first example, oops, is 3 times 1/3 minus 8 divided by 1/4. So we're not just going to go left to right, left to right, left to right. We're going to think about what comes first. Well, I'll take all my grouping symbols, and really the only grouping symbols you could argue I have are fraction bars, but I can just think of those as fractions, that's fine. Exponents and roots, I don't have any. So then I'm going to look for multiplication and division, and I see some. Think about which one we need to do first in this case. And then finally, once we've done both our multiplication and division in some order, you'll figure out which one you'll subtract. I'll let you work through that, but your eventual answer I'll give right here, so pause if you want. Get -31. Okay, example 2. 2/3 times 3/2 squared is 1/4 cubed times 32. Okay. First thing we might do is look at what we have inside parentheses. Now the parentheses are really just grouping those fractions, making it very clear what to do first. This is 2/3 times 3/2. And you might start multiplying these two together and simplifying, except that this one is squared, this one isn't. So we're going to have to start by looking at our exponents. We're going to take 2/3 and figure out that 3 squared is 9, 2 squared is 4, 1 cubed is 1, 4 cubed is 64, 4 times 4 times 4. So I did my exponents at the same time because they weren't interacting with each other, or you can do them in 2 steps. Now I have some multiplication and some addition. Which do I do first? Yeah, start with the multiplication, start on the left. I get 18/12. I just multiplied straight across. Could have simplified early, but that's okay. Plus, put that over 1 to make it a fraction. I have 32 over 64. Let's simplify these. 18 and 12 share what factor? A couple possible answers. The largest one is 6. Divide to get 3/2. These share a common factor of 32. Divide to get 1/2. And now we can add them together. We finally get to the addition. We get 4/2, which is 2. Number 3. Example 3. Negative 14 plus 3 squared plus 8 divided by 2 times 4. Got a few things going on. Notice that you cannot just square the insides. You have to figure this out first, then square whatever you get from this. Notice also, remember that multiplication and division, division and multiplication, they're the same. So how do we, the same priority level, how do we decide which one to do first and which one to do second? Example 4. I have 1.5 plus 3.5 in parentheses minus 2 times 0.5 times 7 squared. Let's go ahead and do this one together. So start with my parentheses. 1.5 plus 3.5 is 5. 0.5 times 7 is 3.5. So I have 5 minus 2 times 3.5 squared. 3.5 squared is like 35 squared. If you take my Topics M127 class, you'll learn a quick way to multiply these. As it is, you can use your calculator in this class, but that's how I know that the answer is 12.25. So I squared it next, I did exponents next. Then I'll multiply. And finally I subtract. 5 minus 24.5. Little minus big. So I'm going to have 19.5. That's the difference. And tack on which sign? Positive or negative? Yeah, negative. Negative 19.5. Example 5. 5.5 minus 3 plus 2 times negative 6. Sometimes we use brackets because we have so many parentheses, it's just easier to figure out, okay, this part goes together, these parts go together, that part goes together. Minus 3 squared plus 2. So we can start with our parentheses, kind of working our way from the inside out. Notice also that negative 3 squared, this part's a tricky part, so I'm going to focus on this. Negative 3 squared. Let's think about order of operations just for that. Do I have any grouping symbols? No. Do I have exponents? Yes. So where do I start? I start with the 3 squared. 3 squared is 9. And then I tack on my multiplication by a negative, by negative 9. So negative 3 squared is negative 9. That's going to be one of your first steps. If we had negative 3 with parentheses around, that's when you say, okay, I'll take my negative 3 times the negative 3, I get a positive 9. But with no parentheses that says square the 3 first, then tack on the negative sign. So this part will be negative 9. Go ahead and figure out the rest. Number 6. have 3 cubed plus 3 over -2 times -3. Let's square that and add -2 squared over 3. So we're going to be figuring out what this piece is, figuring out what this piece is, adding them. We'll add fractions. Maybe they'll have a nice common denominator, maybe they won't. And we'll have to do a little more work. Your answer here does turn out to be a mixed number. So go ahead and keep it as a mixed number rather than an improper fraction. Or have it both ways. That works too. Example 7. 3 plus 2 minus 6 in absolute values. -2, 3 times 1.5. Make sure that your decimal point and your multiplication dots look very different. Minus -3. So we have a number of rules coming into play here. Remember, absolute value strips off the negative if it's negative, leaves it alone otherwise. And finally, number 8. We have 5 times 2 2/3 minus 5 1/2. Let's cube that whole thing. So start with the grouping symbols, start with the innermost, and I'm going to subtract. Even though there's multiplication involved, I start here because of these grouping symbols. Start by subtracting, take the absolute value, multiply by 5, then apply the exponent. Usually we do exponents first, but because of all these grouping symbols, we have to take care of those first. And by the time we take care of all those, we have a single number in here that gets cubed. It is a very messy answer. I'll let you pause if you don't want to see the answer quite yet. I'm not going to work through the whole thing, but I will give you the final answer. As an improper fraction, we get 614,125 over 216. Yuck. And as a mixed number, that is 2843 and 37 2/16. Okay. So again, there's the answer. You need to show the work, but now you have a way to check your work. Let's take a look at worksheets on pages 101 and 102. And I have a quick video on page 102 just to explain that to you. Coming right up.